Welcome to your own channel of Right Funda.
Here is another interesting problem from kinematics. Let's go by the problems, what the statement says. From point A, located on a highway, one has to get by car as soon as possible to point B, located in the field at a distance L from the highway. That is shown in the figure. It is known that the car moves in the field n times slower than that in the highway. Question is asking, at what distance from point M one must turn off the highway? So what question is saying that this is the highway there, and on this highway there is a car here, and car can move on the road, and there is a point the car want to go from this A point to this point B point. A point to B point has to reach. So, but the intention of the car is to reach as early as possible. Suppose some emergency there at B place, and you want to reach as early as possible. Suppose this is a vehicle, it want to reach from here to here at the earliest, at the shortest possible time. So, question is saying that where he will be taking the turn. So, one of the possibility path, different possible path may be possible from A to B. So, how it can be moving so that it can reach at the least possible time. What is the given the question? The speed of the car in the highway is whatever speed is there, it's travel n times slower in the grass field. The speed in the grass field is n times slower. Suppose here it equal to x speed there, it will x by n speed there. So now you have understood the question. Now you may pause the video and you try solving the problem. After trying, again you can resume the video and you can see the solution. I'll be discussing the solution right now. So see, what will be happening here? This car, what are the different paths are possible for the car to go from here to here? We'll see. One of the possible path can be like this. It can go like this, take a turn and come like this. Okay. And some people say that why not? We want to get the smallest possible time. Why not to take the shortest path? We can go like this. From it will start here and go like this, stay straight like this. It will be shortest possible time again. No, not like this. It may be possible that it will go like this and take a turn. It may be possible like this. It may go like this, take a turn. It may go up to this and take a turn. Why I'm telling like this is that why I should not take the shortest possible time? Yes, it will be possible. Shortest possible time is there because the speed is not same. Speed on the road had it been same as the speed on the grass field, then definitely it should have taken the shortest possible time. Now, what the driver may do is that he want to minimize the timing. So first, I think that if you take all the path in the grass field, it will be taking definitely more time, will take more distance. So what will happen? You want to minimize the timing. So what can be done? So you may think that let me cover the maximum out of the pitch road. On the concrete road or pitch road, I look at the most speed. Speed is high there. In the high speed, will cover maximum then, and in the low speed region on the field, I will tell the less than. Is it possible? Or you'll go like this, or you'll take some distance here and take turn. If you go like this, some distance here and take turn, is it possible? Out of this, what is the path? We don't know. So what we'll do, let's assume that there is a point C here. There is a point C here. And let's give some name to this also. This, let's suppose I give the name from this to this point to this point name, I'd give the D distance. Suppose this distance equal to D. I give the name D distance from this to this. What is the point? M point is the perpendicular point is there from C point to this road. So I assume that suppose the car starts from here, goes like this, and from here he took the turn and again travel like this. This is one of the possible paths. So I assume that where it will take turn. Question is where it will be taking turn. So let's assume that this distance is equal to x distance is there. What is x is there? Suppose I take this point from here where he will be taking the turn. I am thinking that this is equal to x. Okay. When this is equal to x, then I'll say, so those people who are thinking that no, he should take the turn here like this, then my answer x should be equal to D should come. If my answer x come out to D, then he will be taking turn from here. If my answer x come out to be equal to 0, then he will take the turn from here. If x is equal to 0, then he will definitely take the turn from this point, he will be taking the turn. Okay. Or if the x is coming L by 2, then the middle point he will be taking the turn. It may go to L by 4 also, whatever distance it may come, x may come anything also. So I don't know. So x is unknown quantity for me, and that is the question is asked where it will be taking the turn. It will be taking so that it will be reaching the minimum possible time. In the minimum possible time, it will be reaching. So let's solve this question. So assume that question is saying that the grass field is travel 1 by n times of the speed. So if I take the speed in the grass field is equal to v naught. So what is the speed in the road over there? N v naught. Or if I say this is equal to v1, this is equal to v1 by n, I can take. This is v1, I will take this speed equal to v1, then equal to v1 by n. Or this I will say v0, then equal to n times of this n v0 speed. So they will be traveling the road, it can travel n v0 speed, and this will be v0 that I have taken. That should not figure out in the answer. So we have to minimize the time. We made the strategy how to solve this thing. We made the strategy. Let's assume that we don't know. Let's x distance take turn, and let's calculate by this method. So we know that with the uniform velocity, when the car is moving, the constant velocity is moving. As the car is moving the constant velocity, then we know simple the time taken to travel any distance is equal to distance by velocity. Okay. So speed we will be dividing. So total time is here. So total time taken from here to here. Time taken. What is the time taken? The time taken to travel from here to here, one time, and again time taken from here to here. Suppose this time is the t in the highway. I given the t in the highway. I have given this. And this time let the t in the grass field, g temple, t here and there. So total time is equal to th plus tg will be my total time. So depending on the x value, it will be changing. So what I will be writing here is that total time is equal to t is equal to t in the highway plus t in the grass field. Okay. What is the t in the highway will be there? Distance traveled in the highway by the speed in the highway. What is the time in the grass field? Time taken in the grass field, distance traveled in the grass field by time speed in the grass field. So I'll revise this one. So how much distance traveled? A to C, it has traveled in the highway. So I have written this one, A to C. AC by the speed in the highway by CB in the speed in the highway. So I have taken the V naught speed in the grass field. So the N V naught in this one. So what is AC? You want to see the AC. What is X there? So this I have taken this A to C is equal to D distance and C to M is equal to X distance. So this distance A to C distance will be equal to D minus X. Okay. So if I substitute the values and in place of AC we'll be writing the D minus X, and what I'll be writing in place of CB? CB will be equal to the Pythagoras theorem. This is equal to L square plus X square ka square root. That I'll be substituting here. So what I got in this case is T is equal to D minus X by NV naught plus under square root of L square plus L square by V naught. Okay. This I can arrange like this. I can write like this. T is equal to V naught I have taken D minus N. There's the first term is a constant quantity. Second term is equal to X by N, and third term is also variable of X. Whatever this time should be minimum, and we know and now we got a t as a function of x. What is the variable? T depend upon the x. X is the distance from the turning point, x from where it will be taking the turn. Okay, and like this, and let's travel. So this is my variable set, and if this quantity has to be minimum, so the first difference of this with respect to variable should be equal to 0. What is the variable? X is my variable in this case. So I'll say dt by dx I require. So let's calculate dt by dx. If you calculate dt by dx, then you got this one. First term difference is 0, second term difference dx x can be 1, and half into this minus half, and the difference, and again the bracketed quantity is equal to x. So this quantity need to be equal to 0 if t has to be equal to minimum. If t has to be minimum, this quantity has to be equal to 0. So if I put this to be 0 and simplify this equation, I got this one as equal to x by square root of L square plus L square is equal to 1 by n. Okay, so I'll take cross multiply both the sides. I got the nx is equal to square root of x square plus x square, and if I square both the sides, then n square x square is equal to x square plus x square, and I'll take this side to x to one side I will take, then I got this relation, and I can find out x square is equal to L square by n square minus 1 n square. I will take the square root, and x is a distance, so it has to be positive quantity, so the only plus value I will taking. So let's take an example. As we calculated x equal to L by square root of n square minus 1, we would take an example. Suppose the speed in the grass field is half time the speed of the highway, or speed in the highway is double the speed of the field in this case. In this case, where it will be taking the turn, if I put here 2, then equal to 4, n square equal to 4 minus 1, 3. So x come out to equal to L by root 3 in that case. So he has to take the turn, the car has to take a turn at a distance L by root 3 from this, so that he'll be able to reach in the minimum possible time. So we have calculated the time where he'll be taking a turn so that the time will be minimum. If the question asks, it will give the value of V0. If they give the value of V0, what speed it can move in the grass field, or he will give the speed in the concrete road, he will give the value speed of the car will be given to us, then even we can calculate the value of time it will be taken to reach from A to B in the minimum possible time by substituting the value what X we got, that value will be substituting here, will we get that minimum time to reach from A to B. So we were unknown about the point where we taking turn, so we take a general value X and we wrote the time from here to here and we minimize the time by the method of calculus and we obtain the result.